So we have done the laws of motion question, second law of motion questions. Okay. After that, we'll be having the third law of motion. Everybody, is that clear? Am I clear to all of you? Any doubts
Yes, sir.
before starting the class?
No.
Okay. Very good. Now let's just give me a moment. Let me. Okay, so let's write down the third law of motion. Okay, so third law of motion says that the normal thing basically. Okay, so let's take example first. Okay, so basically what you will do basically, let's take one example is that okay, so you are sitting in front of a wall. Okay.
Yeah.
Okay, so you are standing, basically not sitting, you are standing in front of a wall. Try to push that wall. Suppose that this is the wall at my behind. Clear? If I try to push that wall, so it seems like I am only pushing the wall. It seems like
Yes.
I am the one only pushing the wall. But in the real scenario, the wall is also pushing some force, is also applying some force on my hand.
Yeah.
Okay.
Yes.
Because that's why if so how many of you remember the balance force?
Yeah, I
I do.
remember, sir.
You remember now? So
Yeah.
Yes, sir.
basically, and how many of you remember the inertia? Greater the mass, the greater the inertia will be.
Yes, sir.
Second law of motion. Yes or no, everybody?
Yes, sir.
Clear? So first of all, I am pushing that. I'm pushing the wall with my one hand, applying some force on it. The same equal force will be applied by the wall as well on my hand. That's called reaction force. This is called as action force. I'm doing action now. Like suppose that you are going in the streets and there is a dog. If you don't say, like if you don't tease him, so it will not say anything to you. But if you tease, or if you basically throw stones to the dog and all the thing, like some students are very like naughty, they do these kinds of things, so it will run behind you.
Yes, it will
Yes,
bark.
na? It will bar, even if it will bite you. Like, don't do this thing because it's very harmful. Clear, na? Okay, so
Yes.
that's very dangerous. So it will harm you as well. So if you have made one action, that's why the dog has made the reaction, because you were the first who throw the stones on him.
Yeah.
Yes or no?
So what
Yes.
about Mad Dog?
What about?
Mad Dog.
No, we are taking the assumption RS. Like sometimes have like there is possibility that it's sometimes dogs and the animals basically you can say apply basically what harms you without any cause. Sometimes happen that, but in the most scenario, just like the animals are very calm. Clear? So you have made the action, that's why the dog has made the reaction on you. Clear? So same thing here. Right now I'm pushing the wall with my hand with a force F. So same force, equal amount of force is applied by the wall on my hand. That's called a reaction force. Clear?
Yeah.
So yeah,
Yes, sir.
yeah. So how many of you seen that, like on just a second. Okay, so basically just take one more example. So you have seen that a farmer is trying
Yeah.
to carry the basically the bull, the buffalo, like in the movies and TVs. So because I belong from a, basically my roots are from village, so I've seen that things as well. So
Yeah, for farming.
yeah, so even the smaller the goats as well, when they don't want to move from their place, so basically they pull themselves away from you. The string gets tightened. The string which is attached to the neck, the rope.
Yeah.
Yeah, na? So you are applying some force, the same, if the animal is not moving, so animal is also applying the opposite force, same equal force. That's why there is no movement. Everybody, yes or no?
Yes.
Yeah, let me take the figure of this, because like I've explained that thing, but let me take the figure so that you can understand the things easily. So in this class, we'll be done with this chapter, like, because only this is the last topic of this chapter only, and conservation of momentum is also there, because so that's a very small topic, not a very lengthy topic. So that 15 minutes is enough, or 15 to 20 minutes is enough for the topics. Okay, everybody, look at the screen. A boy is basically applying some force on the wall. Yes or no?
Yeah.
So same force, same amount of force will be applied by the wall as well on the boy. Clear?
Yes, sir.
Yeah. So that this is one example. One example is that, let me take this example, the buffalo and the ox one. That's a very common example. Like I've seen so many times in my life. During now, how many of you got this point? Got this figure? Got it? Everybody, at least
Yes.
let me know whether it's clear to you or not.
I have seen in
Now
this
see,
cartoons.
you NCFC already also seen in the cartoons as well, but I've seen so many times in the real life. So the farmer is applying some force on this rope. Yes or no? And the bull and the ox, you can say, is also applying some force, so that it basically there is no movement, so forces are balanced. Clear?
Yes.
Yes.
Yeah, that's what the example is. So basically, the third law says that to every action there is an equal and opposite reaction. Clear?
Yes, sir.
Yeah, that's okay. Let me write down the Newton laws of motion. So I've seen like one example, like that was a very funny meme, or you can say the lines. If you slap somebody, you will also get a slap. That's what the equal and opposite reaction. Clear?
Yes, sir.
Yes.
Yeah, very good. That's great. To every action, there is an equal and opposite reaction. Is that clear to everybody?
Yes,
Yes.
sir.
Any doubt?
No, sir.
Sure.
Yes, sir.
That's what the third law of motion is. It's very easy. Clear? So let's understand, like basically like third law is very universal thing, because what we do is basically whatever we do, like whatever is the action of our side, everything when we do, we have got a equal reaction force as well. Suppose that if we are walking, we are pushing, we are applying some force on our foot, by our foot on the
Ground.
on the road, on the ground. Clear?
Yes,
And
sir.
the same force is applied on the foot by the ground.
Yes.
Yes or no?
Yes, sir.
Yeah. So that's why we are able to move.
Yeah.
So you have seen that thing. It's very easy. Like it's very difficult to walk on a slippery ground. Because we don't get any equal force. Like there is a like not proper contact. Basically, not a proper contact is there between, because you have water between your feet and the ground. So there is not a proper contact with you. So water applies very less force. That's why basically your feet get slipped. Clear?
Yes, sir.
When we swim, how do we move forward? Basically, when we these things now, we basically push, we basically apply some force, and the water, we basically pull the water behind ourselves, and the excess of water push you in the front direction.
Yes.
Let me take one example of this. I have one example of this as well. So that's very easy to. So that's a very, you can say, theoretical topic are left in these two parts. So only see this thing. See this thing. So basically, swimmer is pushing the water behind herself, and the water is pushing herself in the forward direction. Is that clear to you, yes or no?
Yeah, it's
Yes,
clear,
sir.
sir.
Clear now? So that's what there is. And the equation for this is, suppose that
Even for this, there is equation. So sad.
no, it's a simple equation here. F1 is equals to minus of F2. Opposite word is used. It means that the F1 is the action force. Let me write action instead of F1. F action is equals to negative of F reaction. So if you take this F reaction force on the left hand side, what will it become? It will become F action. It will be remain minus or positive. Everybody, it will remain negative. If I take this F reaction on the left hand side, will it be positive or will it be negative?
Negative.
How many of you say that negative? Raise your hand. Or let me know. Okay, it would be remain negative. Arya and Abdul says that. Okay, how many of you say that it will become positive if I take on the right hand side of the equal sign, left hand side of the equal sign?
It's me.
Okay, Rima said.
Me.
And what about Abdul said? Abdul, you have that's not good. You are taking you're not allowed to participate in the 2 votes. Only 1 vote is to be counted. Nabila, what do you say? Arya, what do you say? Okay, Arya said the negative one. Okay. What about the other? Okay, so basically here, if I am shifting this thing, this is a negative, and if you are taking on the left hand side of the equal side, so it will become positive, na?
Positive, yes.
Yes,
sir.
positive. And what will be left here? What will be left here? Everybody tell me, what will be left here?
Positive.
What will be left here? If I take this here on this side, what will be left?
2
Zero will be left, because there is nothing, na? Only F reaction was present. And I've taken this on the left hand side, so 0 will be here. Clear? So you can see that if I add the action and reaction forces, the sum of the forces is net force is 0.
0.
Yes or no?
Yes, sir.
Yes, sir.
So do you understand the concept of balance force? Why we have balance force?
Yes, sir.
Balance force are those forces in which the net force is 0. Clear, everybody? Yes or no? At least tell me.
Yes, sir. Yes, sir.
Very good. Now, have you seen that? Just let me example of the. How many of you seen movies in which when they fire a bullet, there is a behind movement of the we can say the gun as well.
Yeah.
Yes.
Yes or no?
Sir.
You've seen that, no?
Yeah.
Yes, sir.
That's also the action and reaction coupling. You can say the action reaction forces. Let
Yeah.
me.
Yeah.
Where is this? Okay, so here is it. I was searching there, like where is it basically? So it's right here. See that this question is. Okay.
Sir, this is done?
This is a rifle.
Yeah.
Yeah. Okay, so don't assume that basically it's an example. Don't go in the wrong way.
No,
Okay.
sir. Half it is hand and half it is gun.
Okay. Yeah. No, it's basically the arm of the gun. Rifle has a wooden block behind it. This is the mechanism part. Mechanical part is this. Till
Yes,
here. Clear? So basically that's okay. So you can see that bullet has the action force because bullet is going in this direction. Okay, and the reaction force will be in the opposite direction. Clear, everybody?
Yes, sir.
Any doubt?
No,
No.
sir.
Okay, one more thing, you have seen that when the car moves on a road, basically what happened? It burns some fuel to get the power. Yes or no?
Yes.
Yeah. So same things also happen. You have seen that there is a burning jet. You can say the burning flame behind the jet, fighter jet.
Yeah.
So why? Because the fuel burns very fast. So that's why the fighter jet is able to move very fast.
Very fast, yeah.
So how many of you done the thing in the childhood? Like you have blow up the balloon and then you have like you just blow up the balloon and then move like
Let
remove
go.
it.
Yeah.
Like
Yeah.
so you have seen that the air comes out and you if you just like leave that balloon so it will go in the forward direction. But
Yes.
there is a backward air propulsion as well. Got it?
Yes.
You have
Yes,
seen
sir.
that? So these everything. Yes, everything with what we have done in the childhood, like everything right now we do. I'm holding a pen. If I'm holding a pen, so a pen is also applying some force on my hand. That's why I'm able to have basically hold the pen because the forces are balanced. If not, pen will slip by my hand, or maybe basically if I apply some extra force, the pen will crush,
Yes.
break. Clear? Is that clear to you, everybody?
Yes, sir.
Any doubt here?
No, sir.
Sure?
Yes, sir.
Any doubt?
No, sir.
So that's about the like basically this complete topic is all about the theory and the example. Nothing more like much more is not present. Only this is present. Every action has an equal and opposite reaction. If you slap somebody, somebody will slap you as well. So that don't do this. Never do this. Okay, that's very
Yes, sir.
bad. Okay, everybody clear? Is that clear to you?
Yes, sir.
Very good. Just give me a moment. Yeah.
It's just like if I slap my brother and my mom come and slap me.
Obviously, like it's not very good, dear. Don't fight.
Sir, first of all, no one can slap mother.
No. She said she said that if I slap my brother and mother will come and slap me. Because the
Why
brother
not?
is younger, na? Younger brother. That's
Okay.
why. In every culture, elder has like every like even it's maybe elder sister or elder brother. So younger cannot like it's a very good because
Say anything.
we are not allowed. It's very bad to argue with the elder person. Okay.
Yes.
So don't do these things in your life. Okay. It's very bad.
Yes.
Sometimes that if it's not your fault, still they do good things for you. Sometimes it feels like that it's very bad. Why did they why did it happen to us? But it's very good for you because you will understand. Because when I was a child, I always think that why happened to me. But when I grew up, I feel that okay, that was correct. I was just completely stupid at that time. I was thinking so much like why happened to me? Why? Yeah. Are you just yes. So is that clear to you, everybody? Third law of motion.
Yes, sir. Yes.
Very good. So let's do the conservation of momentum because there is no numerical on this topic. Okay.
Yeah.
Okay. Just give me a moment. So this is all about. So one more thing is there. I think.
Sir, and third law of motion, is there any theory questions?
Yes, theory questions.
Okay.
A majority of time theory questions. The walking example that I've taken.
Okay, sir.
And the gun recoils. This is the gun recoil example. Gun.
Yes, sir. We can see.
Recoil. Okay. So it's up to you. You can also take like it can be say that like the question can be like this: state third law of motion and explain one example. 3 marks question, one for statement and 2 marks for explanation of the example. So let me take one example of the human body, like the gun recoils. Okay. So when, let me write down the statement for it. When a bullet is fired from a gun, just a second, actually a laptop sending from a gun. This is the most common example of the third law of motion.
Okay.
Sending a bullet in a forward sending a bullet forward direction is equal sorry for the background noise, like there is a fireworks outside my house because of the festive season, so please ignore that. Equal to the force sending the gun backward direction. Okay, everybody, is that clear to you?
Yes, sir.
Yes,
So
sir.
Yes,
so
sir.
whenever, so basically whenever a person fires a bullet, there is a kind of movement in the shoulder, a sudden you can say sudden shock. So that's why it is always prefer, sometimes what happened that the shock is so severe means very dangerous, sometimes the shoulder get breaks.
Yeah,
Yes,
yes.
Yes, so
Yeah.
how many, so like with the rifle, not with the pistol, I'm not, it's not the pistol. Pistol is a small one. You have seen that with the police cops, but this is a rifle. It has like these are carried by the like the constable, police constables, and the army
Yeah, I have seen.
personnel. So that's why the shock is so severe. That's why basically sometimes it happens that the shoulder get broke. Clear?
Yeah.
So that's
Yes,
why,
sir.
yeah. So okay, is that clear? When a
Yes,
bullet
sir.
is fired from a gun, the force sending a bullet forward is equal to the force sending the gun in backward. Clear?
Yes, sir.
Yes,
It's clear.
sir.
Very good. Very good. So let's talk about the conservation of. How many of you remember the definition of momentum? What is basically momentum? Like except Abdul.
Me, sir.
Okay, one by one. Arya, you said first. Okay, go ahead.
Momentum is what do you say? No, sorry. Momentum is the product of mass and velocity of the body.
Yes. Basically, why do we need the momentum quantity?
What?
Why do we need momentum? Basically, why do we need, like, which thing we basically measure from the momentum?
How bad the impact has happened.
Yes.
That
Oh, yes. Okay, very good, Nabila. Like, very correct and crisp answer. That's a very good thing. Arya said the definition and Nabila said the explanation. That's a very good thing. All of you, why, like, Aris and Reem? Okay, so Reem has missed the class. No worries. So Aris, you were there in the previous class, na? Conservation of momentum. Oh, sorry, in momentum part.
No, sir.
You are not there.
Yes. No, I was not.
Okay, no issues. So okay, so go and watch the recordings. Okay, you should
Sir,
have
from where
watched the
can I
recordings.
see the recordings?
Yes,
I'm not
Rima.
able to find. Like, from where can I see the recording?
So
Recorded
basically, if you're not basically in your app account, you will be able to see the recordings here. If not, I will ask the management to share the recordings of my batch with all of you. so that you can at least go through the recordings before coming to the class as just as the revision. Clear? Don't worry about it. If it's not like you're not able to find it, I will ask the management to share that link to you. Clear, everybody? Yes, Ani, you are
Will I
saying?
get it will I get my username and ID and stuff
Yes,
later?
yes, everything, Arya, everything.
Okay.
Everything. Yeah. Everybody will be having a specific ID and account in the app. Don't worry about it.
Okay, thank
Clear?
you, sir.
Yeah.
Yes.
Okay, that's great. So conservation of momentum means, say, suppose that, so how many of you so many times we have seen that thing. Suppose that many times we have seen that two cars basically that's a very unfortunate thing, like sometimes happen that two cars gets collide. Basically sometimes accidents happen
Yes,
on the
sir.
roads. So basically what
Yeah.
happen is that, suppose that one car is here, suppose this is a truck and this is a car. Okay, so suddenly, so what will be the momentum? Suppose that the value of this truck is, the velocity of this truck is u1. U1 is the initial velocity of truck.
Yeah.
Clear?
Mhm.
Mass is m1. Clear?
Yes, sir.
And u2 is the velocity of car, because car will be maybe it can be happen like car will be uh, going in the very, you can say, in a different speed.
Yes.
Yes,
Yes or
sir.
no?
Yes, sir.
Yes.
So a mass of the car will be m2.
Okay,
Yes or
sir.
no?
Yes, sir.
Yeah. So now what will happen is that when they collide, so there's some like the velocity will also get decreased, because when the collision happens, they suddenly stop. And sometimes happen, if now see that there is a truck, so truck will push the car in the backward direction, because truck will be having a greater momentum because the mass is very high of the truck.
Yes.
Yes,
Yes or
sir.
no? So you see that
Yes.
after the collision, what happened is that the truck will go, like truck was going in this direction and car was going in this direction, but and after the collision, truck will be going in this direction, because you and so v1 will be the velocity after collision. V1 is the velocity after collision. U1 is the velocity before the collision of the truck. Okay. M1
Okay, sir.
mass will be same. Clear?
Yes, sir.
And now the car, sorry, just a second, car will also move in the direction if the impact is very high, like if the momentum of the truck is very high, so it will also move it will also push that car in the direction of its motion, because the truck is the higher like higher momentum, is having higher momentum.
Yeah.
Yes.
Yeah.
Clear or not?
Yes,
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 sir.
sir.
Yeah. So that's what basically conservation of momentum says. The momentum before the collision, the sum of the momentum, like this is the momentum of truck plus momentum of car. Initial momentum of truck plus initial momentum of car before the collision will be equal to the after collision. The momentum of the car, maybe car will lose some momentum, but truck will gain that momentum.
Yes.
Okay.
Yes.
Let's give you an example. Just give me a moment. Let me think one example. Let me think one example of this. Just give me a moment. Oh, like just a second. For collisions. Okay. So like right now I'm not able to I'm not getting a proper you can say the example. So I will try to take the example if it strikes my mind. Right here, is that clear to everybody?
Yes,
Yeah.
sir.
Yes or no?
Yes, sir.
Clear now? So basically,
Yes, sir.
this conservation of momentum says that total momentum before collision is equals to total momentum after collision. Clear, everybody? So if I write the equation of this topic, now tell me everybody, the momentum of a truck will be what?
It will be 1.
No, it not be 1. Anybody? Nabila, Arya, Aris, Wasi?
I
Okay,
don't
so
know,
except
sir.
Abdul Wasi, everybody, Arya, Nabila, what is the momentum of truck before the collision?
I don't know, sir.
Okay,
2, sir.
Nabila?
I don't know.
Okay. Yes, Abdul, you are saying something?
2, sir.
No. It will be M1, U1. The formula of momentum, dear, everybody. Yes or no, everybody?
Yes,
Yeah.
sir.
Okay,
Sir,
plus. Total momentum means plus. We are, because car is also present in the scenario, na?
Yes.
Yeah. So M2, U2, clear, is equals to, next thing is the total momentum after collision. What is the momentum of the truck after the collision? Can anybody tell me right now?
Um,
Yes, Arya?
um,
M.
no. M3 and M3.
M3, we have taken M3. Can anybody tell me where is
M3
M3?
and V3.
M1 plus M1.
M1 plus M1, so it would be 2M1. So where is the velocity of the truck? Where is the, like, I think that the momentum has the velocity as well in
Sir,
the
is
equation.
it 0?
Yes, Rima?
Is it 0?
No, it won't be 0.
Sir, will it be M3 plus V3?
M1 V1, everybody, it's simple. M1 V1 and M2 V2 is the final momentum of the car. We are taking the individual momentum and adding them up for the scenario. So this is called the conservation of momentum, which means that before collision, whatever is the momentum is, it will be it will be equals to the after collision as well. Everybody,
Um,
is that clear to you? Yes or no?
Yes, sir.
Any doubt?
yes, sir.
Any doubt?
No, sir.
Sir,
Sure.
No,
can
sir.
you,
Yes.
sir, it is better. Can you explain me once again?
Rima, momentum is the product of mass and velocity of the body. Okay,
Yeah.
so truck
Okay.
has the velocity u1 before collision. So that's why m1 into u1 is taken. Clear?
Yeah.
Plus,
Yeah.
now I'm saying total momentum. So car and truck are present in the scenario before the collision. So car was traveling at a speed of u2. Clear? So m2 will be the mass of the car. So momentum equation will be m2 into u2. Clear?
Yeah. Yes,
Equals
it's
to,
clear.
sign equals is there. Okay, now total momentum after collision. So after collision, what is the speed of the truck? V1?
Yeah.
Yes.
Because it will change some the speed, because before collision, maybe truck would have some different speed, and after collision, it will have some different speed, obviously.
Yes.
Yes. So
Yes, sir.
V1 is the velocity after the collision. So M1 into V1 is the momentum of truck after the collision, plus M2 into V2 is the collision of the car after the collision. Is that clear, everybody?
Yes.
Yes, sir.
Yes, sir.
Any doubt?
Yes. It's,
No, sir.
Sure?
sure,
No,
Yes.
sir.
Any doubt?
No, sir.
No, sir.
So that's what the conservation of momentum is. So conservation of momentum is applied in the recoil of gun. Recoil of gun, this question. Conservation of momentum is applied on this. So let's take the example. What is basically how to solve this question, and we'll be doing the, okay, so let's take the example first.
Sir, this is also rifle, yeah?
Yes, this is also rifle.
Wow.
Wow. See, a bullet of mass 10 gram is fired from a gun. Okay. Mass of the
Yes.
gun is 6 kg. So let's assume that M1 6 kg. Clear? M2 is 10 gram. Now the mass is in gram, so I need to convert that in the kilogram because SI unit of mass is kilogram.
Yeah.
Clear, everybody?
Yes, sir.
So 10 into minus 3 kilogram. Why? Okay, let me take this. If I need to divide, basically, how many grams are present in the 1 kilogram? How many of you know that?
1,000.
Yes, very good. 1,000 gram. So I need to convert this. So basically, so I need to divide this thing by 1,000. So it will become in kg. Yes or no, everybody?
Yes, sir.
Clear?
Yes, sir.
So 1 0 will be done. So it will be 1 by 100 kg. So this is nothing but, can I write this 10 to the power minus 2 kg? How many of you have got this? This word.
Oh.
10 to the power minus 2 kg.
I
So
got
me,
it.
So you got it. Anybody?
sir, I got
Yes, sir.
Okay, very
No,
good.
sir.
Okay.
I
So we
didn't
put
got.
-2 when it's in denominator. Why do you put -2?
Okay. Let me explain that thing. Now see that, can I write 1 by 10 to the power 1 by 10 to the power 2? Because
Yes.
2 zeros are there na? Reem, Arya,
Yes,
Basi,
sir.
Aris.
Yes.
So because of the law of exponent says that when you take the denominator, the power from the denominator to numerator, the power will be become in minus. If the
Okay,
power
sir.
is in minus right here, it will become
Positive.
Yes.
Positive.
Clear, Reem, R is Abdul, Arya is Nabila.
Yes, sir.
Yes, sir.
So that's why I've taken. So this is, so let's remove this part. Just a second. Let me share my screen again. Actually, it got freezed. I'm not able to use the, sorry for that. Let me share my screen first to you. Is that clear to you, everybody?
Yes,
Yes,
sir.
sir.
Let me remove this part. So can I say that if two zeros are present, so after two decimal will be here, kg. Clear, everybody? Yes or no?
Yes, sir.
Okay.
Yes.
So okay. Velocity of the bullet is 300 meter per second. Okay. So velocity. Okay, tell me, what was the velocity of the bullet before the firing?
0.
0. I'm just checking whether you know or not. Okay. So V is equals to 300 meter per second. It's V2. Clear?
Yes.
We need to
Yes,
find the
sir.
velocity of bullet. Oh, sorry, rifle. Clear? So can I say that recoil of bullet is equals to firing of gun, basically mass of gun into mass of gun, na mass.
Yes, sir.
Yes, everybody. Into recoil of gun. Gun will move in this direction. Yes or no, everybody? So gun will be having some
Yes, sir.
velocity as well. Gun
Yes, sir.
equals to mass of bullet into velocity of bullet. Bullet is moving with the velocity. Yes or no?
Yes.
Yes, sir.
Very good. Put the values. Mass of gun is 6 kgs. 6 into mass. We need to find the velocity of basically the gun. So can I write in V1? We have taken V1 na? Equals to, clear, everybody? Clear or not? At least say to me anything. How
Yeah.
many of you are getting this equation?
Sir, I did not understand.
Okay. Arya, momentum. We are taking the momentum here because it's asking the recoil velocity of gun. So recoil velocity will be taken because mass is given and the velocity is asking. It means that only the momentum in concept will be introduced. Clear?
Yeah.
Mass of the gun is here, and into if I multiply this with the velocity of a gun, because gun will also move in this direction with some velocity.
Yeah.
Clear?
Yes.
So recoil velocity is the word used because it's a recoil. Recoil, whenever the fire a bullet, there is a recoil velocity of the gun. So recoil velocity is nothing but when the gun moves in the opposite direction. Clear?
Yes.
Is equals to because initial momentum is 0. Like gun is also at rest, bullet is also at rest. So initial momentum is 0. We are talking about the scenario when we fired the bullet. Clear? Is
Yes,
equals
sir.
to mass of the bullet. So bullet mass is there into, if I need to calculate the momentum of bullet, what you need? You need the velocity of the bullet. So velocity of the bullet is also given. So that's how the momentum of bullet is equals to, because when you fire the bullet, the same force which will send the bullet in the forward direction, the gun will also move in the backward direction with the same force. Third law of motion.
Yeah,
Yes, sir.
Clear?
Yes, sir.
So can I say that mass of the bullet is 0.01 into velocity of the bullet is 300?
Yes.
Yes, sir.
Very good. So V1. So 2 zeros are there and 2 zeros are there. Yes, Reem?
Sir, I have problems that I can't keep in mind any equations that you're giving.
You are not?
I can't keep any equations in my mind which you are giving.
No
Okay.
brain.
Okay, well, Reem, the only thing is that you have to revise the equations again and again, because even learning in the one time, it's not possible to understand and remember all the equations for only for one time. But you have to practice and okay, so that's why you can keep the equation in your mind when you when you revise the concepts. Clear, everybody?
Yeah.
Yes,
Okay.
sir.
So now two decimals are there. Yes or no, everybody?
Yes, sir.
Yeah.
So can I say that? So let me do one thing. 0.1 into 300 divided by 6 will be in there.
Yes.
6 was in
Yes, sir.
multiplication. It will go in the denominator. V1 is equals to 0.01 into 300. So 2 zeros are there and 2 decimals are there. 2 zeros will cancel out the 2 decimals. Yes or no, everybody? So 3 by
Yes.
6 will be left.
Yes, sir.
So 3 by 6 is nothing but 1 by 2 is 0.5. Meter per second, kilometer per hour, what? Tell me.
Um.
Everybody,
Yes, sir.
tell me.
Meter per second.
Meter per second.
Meter per second. Because I have already, everything is meter per second, and meter per second kg. So everything will be in SI unit. So meter per second is the SI unit of the speed of the gun.
Yes, sir.
So that's what the recoil of the gun, which means that gun will move in the direction with a speed in the backward direction with a speed of half meter per second. Why the velocity is less of the bullet gun with respect to bullet? Because the mass of the gun is very high in comparison to bullet. It's 6 kg and it's 10 gram. It's almost negligible. 6 kg is very heavy and 10 gram is nothing but maybe 10 gram is like the pen which I'm basically holding. Maybe it's greater than 10 gram.
Yes.
And 6 kg is very heavy, very heavy.
Very heavy.
Yes or no? So that's
Yes,
why
sir.
it balances out. If the mass is very high, so velocity will become less. And if the velocity is very high, the mass will become. So in case bullet, the velocity is very high, but the bullet mass is very low. That's why bullet is able to move with a very high speed.
Yes,
Even
sir.
this half meter per second speed is very high for the human shoulder. It will break. Okay. So that's why we need the proper, basically that's why training is necessary for the proper use of rifles and all the big guns. In the army, in the police, in the self-defense centers. So proper training is required. Clear, everybody?
Yes, sir.
Yes.
Any doubt?
No,
No,
sir.
sir.
Sure?
Yes, sir.
Yes.
Okay, that's great. So just let me check whether only I think 2 to 3 numericals are there. So I'll be giving that to you in the homework because it's already time. We don't have enough time for right now. Okay, so everybody, that's the chapter is done. Okay. The force laws of motion is a very small chapter, not a very big chapter. Okay, everybody?
Yes.
Sir.
Okay, so that's all for this chapter, and we are done with the laws of motion chapter. And the next chapter, which chapter should I start? Everybody, one by one. Reem,
Motion.
Abdul,
The gravitation.
okay, Aris, you said something, gravitation.
Gravitation.
Nabila,
Sir, I'm also doing gravitation.
gravitation. Arya,
I'm also
Motion.
doing gravitation.
gravitation. Abdul, basically motion is already done in the batch. So what I will do, I will try to manage, I will tell you what is basically possible. Okay.
So me as well.
Yes, Nabila as well, and Arya as well.
Yes.